Welcome back to the channel, and today we are going to be reviewing the thyroid gland and the hormones that are produced by the thyroid gland. Okay, so we are going to basically first look at the functional anatomy of the thyroid gland. From there, we are going to look at the hormones that are produced by this thyroid gland, and then we are going to look at the synthesis of these hormones. And then after that, we are going to look at the mechanism of action of these thyroid hormones. How are they transported? How are they stored? And how do they exert their exact effects in the different organs of the body? But specifically, in the first video, we are going to look at functional anatomy. Then we are going to look at the hormones that are produced by the thyroid gland. We are going to look at the synthesis of thyroid hormones. And then we are going to look at the storage, release, and transport of these hormones. And lastly, we shall look at the control of release of the thyroid hormones. And then in the next video, that's where we shall going to continue and look at the mode of action, okay? And then also the effects of these hormones. So let's dive into our today's content. When we talk about the thyroid gland, what do we mean? A thyroid gland is a gland that is found around the trachea. Okay, so when you look at what we call the voice box, what we refer to as the larynx, okay, we can zoom into this thyroid gland and then we shall look at these cells. But before that, I want you to understand that this thyroid gland has lobes, okay? We call these lobes. We have the right and the left lobe, and they are connected by what we call the isthmus. Okay, this that connects the right and the left lobes. When we zoom into this, we shall find that the thyroid gland is composed of these different cells, and these are the cells that we call follicular cells. Okay, follicular cells, and so they are always surrounding the thyroid gland. And then we also have small cells that we call parafollicular cells. Okay, so the main cells are the follicular cells, and those are the ones that we are going to focus on, because these other ones produce what we call calcitonin, a hormone that is related in calcium metabolism. But we are not going to concentrate on calcitonin for today. We are going to concentrate on these follicular cells that produce hormones, okay, of the thyroid that we call thyroid hormones. Thyroid hormones. And these are basically two. We have what we call T4 and T3. In other ones, or in other names, you can call this tetraiodothyronine, okay? And this is called triiodothyronine. But also this is mostly referred to as thyroxine hormone. Okay? So, to review, they are saying the thyroid hormones, T1, T3, or tetraiodothyronine and triiodothyronine. And we are saying T4 is also commonly referred to as a thyroxine hormone, and T3 is always called T3 or triiodothyronine. So let's look at the synthesis of these hormones. But before we look at that, we need to understand that this thyroid gland produces about 80 to 90% of the hormone it produces is actually T4. Okay, meaning the remaining about 10 to 20% is actually T3. But the thing that we need to understand is that whereas we have a very small percentage of T3, T3 is about 100 times more potent than T4, and therefore this is the active form. Okay, T3 is the active form of thyroid hormones. And we shall find that in the body or in the cell, T4 is always converted to T3 so as to be able to exert the effect. So this is the active form of the thyroid hormones. All right, so let's come here and understand how actually these hormones are manufactured by these follicular cells. Okay, so these follicular cells that we have looked at, these are all called follicular cells, and they surround something in between here that we shall call the colloid. Okay, the colloid. So let's pick one cell and zoom in here and understand how they are actually synthesizing. Now, this is a blood vessel, okay, and there is blood moving, and then this is the follicular cell, and this is going to be our colloid, okay. So in other words, we would be having a lot of other cells surrounding the what? Surrounding the colloid. So, to be able to manufacture these thyroid hormones, we need about two things. One, we need tyrosine, okay, and then another one, we need iodine. Something that you need to understand is that your body needs about 150 micrograms of iodine each day. But good enough, the body stores about, or the thyroid stores about 8,000 micrograms of iodine. Okay, so meaning even if you do not get iodine within about 50 days, your body has a store that can be able to pick on and produce these hormones for about 50 days before you get into a deficit of these hormones. So let's see how where do we get these components and how does the body manufacture them. Okay, so we are saying this is our blood vessel, and iodine, normally when we ingest iodine, normally we get iodine from foods like eggs, we get iodine from foods like seafoods, seaweed, but also in some areas where we do not access iodine, we take iodinized salt, and therefore we always get iodine from those things that I've talked about, okay, eggs, seafoods, and iodinized salt. Okay, so when you take iodine, the body cannot be able to absorb iodine in its normal form of iodine. Therefore, what it does is that it converts it to iodide. Okay, and therefore your body now can be able to absorb iodide. So what happens is that this iodide is going to be absorbed from your bloodstream into the interstitial space, okay, and then it's going to be taken up by your follicular cells as iodide by a symporter, which is iodide sodium symporter. Basically meaning that it is a pump that pumps inside both iodide and sodium. But of course, this is a secondary kind of transporter, and therefore we have a primary transporter here. The potassium, the sodium, the potassium, sodium transporter. And this is the primary kind of transport that provides the energy that is needed for this secondary active transport. So we have brought in our iodide, okay, into the follicular cell. So we have it here, iodide. And then this iodide is turned into iodine in a process that we call oxidation. Okay? So we lose the charge and then we get our iodine that we need. Then we also need to understand that we've said we need tyrosine. So where do we get tyrosine? Now, the body manufactures what we call TG, okay, or what we call thyroglobulin. This is a glycoprotein, and it is none other than basically a series of tyrosine, okay. It has different or very many amino acids which are basically tyrosine. Okay, so we have our thyroglobulin, which is a glycoprotein that has different tyrosine molecules. We also have our iodine in its normal state. So now this iodine, okay, that we have here is going to be brought into the colloid. Okay, remember we've said this is a colloid through a channel that we refer to as pendrin. Okay, through pendrin. So we have iodine here, but also this thyroglobulin is also going to be channeled into our colloid. Okay, now let's put steps. This first step here is what we call iodine trapping. Okay, iodine trapping. And then the second one here is what we have called oxidation. Now now that we have our two components that we need, our thyroglobulin that has tyrosine and iodine, the next step that is going to follow, or this third step, is what we call organification. And what does organification mean? Organification means that we are going to get iodine and we add it to tyrosine. Okay? So, how do we do that? Or how does that happen? This is our tyrosine molecule. We can add one iodine, or we can actually put two molecules of iodine. Okay? The one that has one iodine shall find that we call it MIT, monoiodotyrosine. The one that has two iodine molecules, okay, remember here we've attached two, so we call this DIT, diiodotyrosine. All right? So this is the second step, organification, addition of iodine to tyrosine molecules or residues. Now, the next or the fourth step, okay, is what we are going to call coupling. So what is involved in coupling? What is involved in coupling is the addition of these elements or of these products that we already have, MIT, DIT. So, look here. We can add MIT and DIT. And what are we going to get here? The result that we are going to get here is T3. But also we can add DIT plus DIT. Okay, diiodotyrosine. When we add them together, it means we are going to have T4. Okay, so now we already have T3, we have T4, which are our hormones here, but also we still have DIT and MIT. And therefore, what is going to happen is that all of these are going to be packaged in one vesicle. And this vesicle, by exocytosis, or by endocytosis actually, by endocytosis, they are going to come back into the follicular cell. From the colloid, it's going to be endocytosis back into the what? Into the follicular cell. And remember, in this follicular cell, we have there, let's put it here, we have lysosomes. And what do lysosomes do? Lysosomes always do cleavage, okay? They do cutting. So they are going to help us to cut this vesicle, and they're going to separate different products. So we are going to have T3 separate, we are going to have T4 separate, then also we are going to have some DIT and MIT. So we can call this actually the fifth step, endocytosis of the products. And inside here there will be cleaved. And therefore we have T3, T4, DIT, MIT separate. So now we are going now to have these hormones which are ready. They are going to be taken out of this cell through exocytosis, and then they can come into our blood vessel. Okay, they can come back into circulation, and therefore they are ready to go and have an effect in the different organs and the different cells of the body. But remember, like I've already told you, the body produces about 80 to 90% of T4, but the active one is T3. So when it reaches in the cells or in target areas, T4 is converted into T3, the active form, by an enzyme that we are going to find that is called deiodinase. Okay? In medical, when we talk about D, it means removal. So we remove one iodine from T4 to be able to get a T3. Okay? So we've looked at functional anatomy, we've looked at the hormones, how they are synthesized, how they are stored, and how they are released. So this is how they are released. Let's look at control. We want to understand how is the secretion or how is the release of these hormones controlled. Okay, so let's come here. We are having the hypothalamus, okay? This is our hypothalamus, okay? And then the hypothalamus, you know, it has, below it, we have the pituitary gland. And the pituitary gland has the anterior, okay, and the posterior pituitary gland. Now, the hypothalamus produces a hormone that we call thyroid releasing hormone. Okay, so this hormone travels through what we call the hypophyseal to the anterior pituitary gland and instructs it to produce a hormone that we refer to as thyroid stimulating hormone. Okay, so let's forget about the posterior pituitary gland for now, because this produces other hormones like oxytocin, ADH, and others. Let's concentrate on the anterior pituitary gland. So this TSH, or what we have referred to as thyroid stimulating hormone, okay? It travels and comes to the what? To the thyroid. Okay, so we are having TRH from the hypothalamus coming to the anterior pituitary gland and instructs it to produce TSH, and therefore TSH travels to the what? To our thyroid gland and instructs it to produce, or influences it to produce, our T3 and T4 hormones. Now, it is controlled through what we call a negative feedback mechanism. Negative feedback mechanism means that when we have T3 and T4 in very big amounts, or in large amounts, or in excess, it is going to go back to the hypothalamus and says, hey, look, there is a lot of T3 and T4. Therefore, you reduce the secretion of what? Of TRH. And the reverse is also true. If you have very low levels of T3 and T4, this information is also going to go and reach the hypothalamus and say, look, there is less of T3 and T4. So increase the production of TRH, or thyroid releasing hormone. This is also going to, when it increases, it is going to come to the anterior pituitary gland and says, listen, increase the production of TSH, and therefore TSH will increase, come to the thyroid gland, and also increase the production of T3 and T4. So that is basically how this is controlled in normal physiological means. All right? So this is basically what we are going to cover in this video, and the details of the mode of action, and also about the functions or the effects of the thyroid hormones are going to be covered in the next video. Only that maybe we can, in summary, look at what are some of the effects of these hormones. One, the most effect is to increase what we call BMR, basal metabolic rate, okay? And also it has an effect in CVS, or the cardiovascular system. It increases the heart rate, it increases the contractility of the heart. So when you increase contractility, of course, you will increase the stroke volume, you will increase the cardiac output, and therefore, if it is high, it can lead someone into hypertension. Then also on the central nervous system, it augments the effects of the sympathetic nervous system. So actually we say that thyroid hormones are sympathomimetics. They increase the effects of the sympathetic nervous system. But also they are very important in mentation or in development of neurons. In respiration, they increase the ventilation rate. In GIT, or in the gastrointestinal tract, they increase the secretion of different GI secretions, and also increases motility. Okay? And on bones, they help to balance the effects of osteoclasts and osteoblasts. And also, lastly, they have a very big effect in growth. And therefore, if you lack these hormones, it means you might have a stunted stature. So thank you very much. Remember to subscribe and follow for more. Look out for the next video. Thank you.